Hello students, some more questions I will take in a class. As I taken one question on the board here. Figure shows a graph in between degree Celsius versus degree Fahrenheit. Then the value of sine theta is, this graph is given in the question, degree Celsius versus degree Fahrenheit. Degree Celsius should be along y-axis, degree Fahrenheit should be along x-axis. Theta is mentioned, we have to find out the value of sine theta. Now, question is arising how to find out the value of sine theta. But before discussing the value of sine theta, one question is arising here. This straight line is passing through origin. So how this straight line is passing through origin? In the previous questions we have taken either straight line passing through positive x-axis and negative y-axis, or negative x-axis and positive y-axis. But here it is not. Here straight line is passing through origin. So that must be clear first in a class. How that straight line is passing through origin? You know it here. C is equal to 5 by 9 of f minus of 32. This C is equal to 5 by 9 of f minus 5 by 9 into 32. It was the straight line equation, but this is not the straight line equation for this graph here. Okay, here a straight line is passing through origin. So this straight line will pass through origin only whenever the value of this factor will be equal to 0. Whenever the value of this factor will be equal to 0. If it is equal to 0, C will become equal to 5 by 9 of f. Now this equation we can compare with the equation of a straight line y is equal to mx. Y is equal to mx. Now the picture is clear here. How this straight line is passing through origin. This straight line will pass through origin only whenever this value will become equal to 0. And if it is equal to 0, equation will become C is equal to 5 by 9 of f, and this equation is comparing by the equation of a straight line y is equal to mx. Y is equal to mx. Yes, C is along y-axis. C is along y-axis and f is along x-axis, and m is the slope. M is the slope. So slope is equal to 5 by 9. Slope is equal to tan theta. Slope is equal to tan theta. So the value is on the board now. M is equal to slope, and slope is equal to tan theta. Tan theta is equal to 5 by 9. So the value of tan theta is equal to coming 5 by 9, but it is not required. What is required? The value of sine theta. If we know tan theta, we can find out any value of theta. If we know tan theta, we can find out the any value of theta, or including sine theta also. So tan theta is 5 by 9. We have required the value of sine theta. We can take the diagram of a triangle. Yes, is a diagram of a triangle. Here it is theta. This value is 5 and it is 9. Perpendicular upon base. Perpendicular upon base. It is 5, it is 9. Now by Pythagoras theorem, this value will become equal to root over 106. Now this value root over 106, what we have required it here, the value of sine theta. Yes, tell me now, what is the value of sine theta is equal to this P upon H. P upon H, 5 by root over 106. So that was the required value of a question. Sine theta is equal to 5 by root over 106. Okay, next question. Figure shows a graph in between degree Fahrenheit versus degree Celsius. Then the slope of a straight line passing through negative x-axis and positive y-axis. These are the four options given on the board. We have to find out the value of slope with the help of this diagram. Yes, this slope is passing through negative x-axis and positive y-axis. How to find out the value of slope? Now, as I told you in the previous question here, we can take the concept of lower fixed point and upper fixed point. Tell me now, what is lower fixed point on centigrade scale is 0 degree Celsius. When the lower fixed point on centigrade scale is 0 degree Celsius, what is lower fixed point on Fahrenheit scale will be equal to 32 degree Fahrenheit. I repeat again, when the lower fixed point on centigrade scale is 0, lower fixed point on Fahrenheit scale will be equal to 32 degree Fahrenheit. Now what is upper fixed point on centigrade scale? If it is lower fixed point, here will be upper fixed point. So what is upper fixed point upper fixed point on centigrade scale, yes, it is 100 degree Celsius. So when the upper fixed point on centigrade scale is 100 degree Celsius, what is upper fixed point? Upper fixed point on Fahrenheit scale will be equal to 212 degree Fahrenheit. 212 degree Fahrenheit. I repeat again, when the lower fixed point on centigrade scale is 0, then the lower fixed point on Fahrenheit scale is 32 degree Fahrenheit. When the upper fixed point on centigrade scale is 100, what is upper fixed point on Fahrenheit scale is 212 degree Fahrenheit. So this is the coming diagram on the board. Now what we have to find out the value of slope. Yes, slope we can find out now here. Yes, tell me now. We can draw this line. We can draw this line here for finding the value of slope. Suppose this angle is theta. Suppose this angle is theta. Not asking theta. What is asking? Slope. Slope means tan theta. Tell me now, what is this length is equal to 100 minus 0. 100 minus 0. So this length will become equal to 100. This length will become equal to 100. Now what is this length? 32. This length 212. So what is difference in length? 180. So this is equal to 180. So this length is 100, this length is 180. What we have to find out the value of slope. So slope is equal to tan theta, and the value of tan theta will become equal to once again perpendicular upon base. Perpendicular upon base. So what is perpendicular is 180, base is 100. This is equal to 9 by 5. So it must be clear here. Slope is not always 5 by 9. It may also be 9 by 5 depending upon the conditions. Depending upon the conditions. So what is answer is 9 by 5. Next topic is now types of thermometer. Types of thermometer, we have to discuss now number of type of thermometer like liquid thermometer, gas thermometer, resistance thermometer. Resistance thermometer is also known as platinum resistance thermometer. Next, it is thermoelectric thermometer. Thermoelectric thermometer is also known as thermocouple thermometer, radiation pyrometer, vapor pressure thermometer, magnetic thermometer, sixth thermometer. Number of type of thermometer we have to discuss in a class. Question arises, all these thermometers are based on which principle? What is the principle of all type of a thermometer? Yes, what is the temperature range of different type of thermometer we have to take in a class? What is the temperature range of different type of thermometer? How to extend upper range? How to extend lower range? Which thermometer is the most accurate thermometer? Which thermometer is used to calibrate other thermometers? Which thermometer can be used as a scale? Which thermometer is the most sensitive thermometer? Which thermometer is used in motor engine? Which thermometer is used to measure very low temperature? Which thermometer is used to measure very high temperature? Number of possible questions are arising here. We will discuss one by one in a class here. So first thermometer we want to take in a class, it is liquid thermometer. So first one is liquid thermometer. Okay, liquid thermometer. Yes, question is arising, what is the principle of a liquid thermometer? Simple, the principle of a liquid thermometer, as you know, temperature increases, volume of all liquid increases. Temperature increases, volume of all liquid increases. So what we can take the principle, it is based on the principle of change in volume with rise in temperature. It is based on the principle of change in volume with rise in temperature. That is, delta V is directly proportional to delta T. Delta V is directly proportional to delta T. So temperature increases, volume of all liquid also increases. So delta V is directly proportional to delta T. So delta V is directly proportional to delta T. This is the principle of a liquid thermometer. Delta V is directly proportional to delta T. Now, what is temperature range? Temperature range is from minus 39 degrees Celsius to 357 degrees Celsius. This is the temperature range of a mercury thermometer. So this is the temperature range of this thermometer, mercury thermometer. Lower temperature range of mercury thermometer is minus 39 degrees Celsius. Upper temperature range of mercury thermometer is 357 degrees Celsius. Now few questions arising here. Why mercury cannot measure the temperature above 357 degrees Celsius? Why mercury cannot measure the temperature below minus 39 degrees Celsius? Simple. Yes, mercury cannot measure the temperature above 357 degrees Celsius because above 357 degrees Celsius, mercury starts to vaporize. Mercury starts to vaporize. The boiling point of the mercury is nearly 357 degrees Celsius. So above this temperature, mercury start to vaporize. If mercury start to vaporize, yes, it will not be a liquid thermometer, will converting into a gas thermometer, converting into a gas thermometer. So why mercury cannot measure the temperature above 357 degrees Celsius? Because above this temperature, mercury start to vaporize. Now, another here, mercury cannot measure the temperature below minus 39 degree Celsius. So, why mercury cannot measure the temperature below minus 39 degrees Celsius? Yes, below minus 39 degrees Celsius, mercury start to freeze. Mercury starts to freeze. If mercury start to freeze, it will converting into a solid form, and it is not a solid thermometer, is a liquid thermometer. So, mercury cannot measure the temperature above 357 degree Celsius because above this temperature, mercury starts to vaporize, and mercury cannot measure the temperature below minus 39 degrees Celsius because below minus 39 degrees Celsius, mercury start to freeze. Now, again question is arising here. How to measure a temperature up to 550 degrees Celsius? How to measure a temperature up to 550 degrees Celsius with the help of a mercury thermometer? With the help of a mercury thermometer. I told you just previously here, yes, we cannot measure the temperature up to, we cannot measure a temperature more than 357 degrees Celsius. But we want to measure a temperature up to 550 degrees Celsius with the help of a mercury thermometer. How it is possible? Simple here. By filling nitrogen over mercury. By filling nitrogen over mercury. So suppose this is a thermometer here, is a mercury now here. Yes, by filling nitrogen over mercury under pressure. Under pressure. So nitrogen is filling over mercury under pressure. What does it mean by this? Whenever temperature increases. Whenever temperature increases. Yes, this mercury will expand. Nitrogen gas will also be expand, but which one will expand more? Is it mercury or nitrogen? Yes, it is nitrogen. Nitrogen is in a gaseous form. Yes, expansion will be more of gases than liquid. Yes, mercury is in a liquid form. Nitrogen is in a gaseous form. So whenever temperature increases, mercury will expand. Mercury will expand. Nitrogen will also be expand, but expansion of the nitrogen will be more than mercury. Expansion of the nitrogen will be more than mercury. So this mercury above 357 degrees Celsius, this mercury will try to convert from liquid form into gaseous form, but due to high pressure exerted by nitrogen gas on the mercury here, mercury will not be able to convert from liquid form into gaseous form. So by filling nitrogen over mercury under pressure, we can measure a temperature up to 550 degrees Celsius. So this is the 357 degrees Celsius to 550 degrees Celsius by filling nitrogen over mercury under pressure. So by filling nitrogen over mercury under pressure, this range may be extended up to 550 degrees Celsius. Yes, mercury cannot measure the temperature below minus 39 degrees Celsius. Now we want to measure a temperature up to minus 110 degrees Celsius or minus 112 or minus 114 degrees Celsius. Yes, everybody know here mercury cannot measure the temperature below minus 39 degrees Celsius, but we want to measure a temperature below minus 39 degrees Celsius by replacing mercury by alcohol. By replacing mercury by alcohol. Alcohol can measure a temperature up to minus 114 degrees Celsius. So by replacing mercury by alcohol. So this is the part here, and it should be clear here, both range will not be takes place at a time. Okay, both range will not be takes place at a time. If we want to measure a temperature up to 550 degrees Celsius, we have required this condition, and if we want to measure a temperature up to minus 114 degrees Celsius, we have to require this condition. Otherwise, generally mercury can measure a temperature from minus 39 to 357 degree Celsius. This is the temperature range of a mercury thermometer. Okay, some more questions are possible to arise here now. Yes, mercury. Mercury is preferred over other liquid thermometer. Why mercury is preferred over other liquid thermometer? Because mercury has low specific heat and high thermal conductivity. What does it mean by low specific heat and high thermal conductivity? Low specific heat means low absorption of heat. Low specific heat means low absorption of heat, and more thermal conductivity means faster transmission of heat. This is the property of mercury. This is the property of mercury. So what is the property of mercury? It will absorb less heat due to low specific heat. It will absorb less heat and it will transmit more heat due to more thermal conductivity. Due to more thermal conductivity. So what is the property of mercury? It will absorb less heat and it will transmit more heat is the property of mercury. So why mercury is preferred over other liquid thermometer? Because mercury has low specific heat and high thermal conductivity. But again question arises here, alcohol thermometer is better than mercury thermometer. Why alcohol thermometer is better than mercury thermometer? Simple reason behind it here, accuracy of alcohol is better than mercury. Accuracy of alcohol is better than mercury. But again question arises here, sir, how it is accuracy of alcohol is better than mercury? You know it here, density is equal to mass per unit volume. Density is equal to mass per unit volume, keeping mass constant of the both. Keeping mass constant of the both, volume and density both will have inverse relation. Volume and density both will have inverse relation. Now alcohol is lighter, mercury is heavier. Keep in our mind, mercury is heavier, alcohol is lighter. So if alcohol is lighter, lighter means yes, alcohol will have lower density than mercury. Alcohol will have lower density than mercury. So the lower density of the alcohol, greater will be the expansion. Greater will be the expansion after rise in temperature. So the lower density of alcohol, greater will be the expansion of alcohol after rise in temperature, and higher the density of mercury, yes, lower will be the expansion, of mercury. So expansion will be more of alcohol than mercury. Greater the expansion, better the accuracy. So due to greater expansion of alcohol, accuracy will be more of alcohol thermometer than mercury thermometer. Now again question is arising here, sir, why accuracy will be of more of gas than liquid or solid? Simple reason here, you can take here same quantity of gas, liquid and solid. You can take same quantity of gas, liquid and solid, and when same amount of the heat is supplied for all three. What happens here? Yes, there will be more energy will be required for solid molecules to separate it here. There will be more energy required for solid molecules to separate it here than liquid molecule, and the minimum energy will be required for the gaseous molecule to separate it here. What is the reason behind it here? Due to intermolecular force. Intermolecular force is maxima in solid, so the more energy will be required to separate the solid molecules than liquid molecule, and in case of gas molecule here, a very less energy is required to separate the two gas molecule or air molecules. So minimum energy required for gaseous molecule to separate it here. Minimum energy required means there will be minimum loss of energy. And there will be maximum loss of energy in the solid molecules to separate it here. So minimum loss of energy will be more expansion. There will be more expansion. Greater the expansion, better will be the accuracy. And in case of solid molecule, yes, more energy will be required to separate the two molecules. So there will be more loss of energy, less expansion. And due to less expansion, accuracy will be less. Okay, in the beginning of a same thermometer, liquid thermometer, we have discussed one statement in a class, principle. It is based on the principle of change in volume with rise in temperature. So change in volume with rise in temperature, temperature increases, volume of all liquid also increases. So delta V directly proportional to delta T. Now delta V is also directly proportional to V naught. Higher the original volume, higher will be the change in volume. Higher the original volume, higher will be the change in volume. Lower the original volume, lower will be the change in volume. But I think this is not clear for all students. Yes, how to understand by the example? Okay, how to understand by the example? Suppose this value is V naught is equal to 5 milliliter and one more V naught is equal to 5 liter. Okay, this is 5 milliliter and this is 5 liter. Both are the original volume of a liquid. Now, whenever it is heated, its expansion will be 5 milliliter to maybe 5.1 milliliter. Expansion may be 5 milliliter to 5.1 milliliter, and whenever this one is heated here, its expansion will be supposed to be changes from 5.5 milliliter to 5.1 liter. So this expansion 5 milliliter to 5.1 milliliter. Now this expansion 5 liter to 5.1 liter. What is change in volume? It is 0.10 milliliter. Now this is a change in volume. This is a change in volume 100 milliliter, 0.1 milliliter. And this value is equal to 5 liter. It is 5.1 liter. What is change in volume is equal to 0.10 liter. So this is 0.1 milliliter. This is 0.10 liter. It is equal to 100 milliliter. 100 milliliter. So this value is very large as compared to this here. So what does it mean by this here? More original volume. More original volume. More will be the change in volume. Less original volume. Less will be the change in volume. So this is clear now here. Delta V directly proportional to delta T and delta V directly proportional to V naught. Now, these two relations will now be helpful to develop a mathematical relation for solving the numericals here. Yes, tell me now, delta V is directly proportional to V naught delta T. Delta V is directly proportional to V naught delta T, or this delta V is equal to V naught gamma into delta T. This is the value of change in volume. So change in volume is equal to V naught. A constant term is gamma into delta T. Gamma is a constant term, is known as coefficient of cubical expansion of a liquid or coefficient of volumetric expansion of a liquid. Coefficient of cubical expansion of liquid or coefficient of volumetric expansion of a liquid. So delta V is equal to V naught gamma into delta T. Delta T is a change in temperature. Change in temperature. So delta V is equal to V naught gamma delta T. We are developing a mathematical relation for solving the numericals here. Tell me now, this delta V, can you be right here? It is equal to Vt minus V naught. Vt minus V naught. Change in volume is equal to Vt minus V naught. Final volume minus initial volume. Change is always final minus initial. Change is always final minus initial. So final volume is at T degrees Celsius minus initial volume is at 0 degrees Celsius. So Vt minus V naught is the change in volume is equal to V naught into gamma into what is change in temperature is T minus 0. Yes, it is T minus 0. So one relation we are developing in a class here for the change in temperature Vt minus V naught. Now one more relation we will develop now here. If final volume is at 100 degrees Celsius, if final volume is at 100 degrees Celsius minus initial volume is at 0 degree Celsius and it is equal to V naught into gamma into what is change in temperature will now become equal to 100 minus 0. 100 minus 0. So it should be clear both relations are developing from here. Change means always final minus initial. Change means always final minus initial. So it's a final volume minus initial volume. Here is another final volume minus initial volume. Change in temperature here is T minus 0. Here change in temperature is 100 minus 0. So both relations are developing from here. Is supposed to be taken as relation number 1. This is taken as relation number 2. Now dividing 1 divided by 2. So dividing 1 by 2 now, yes, it is Vt minus V naught divided by V100 minus V naught is equal to V naught into gamma into T minus 0. T minus 0 is equal to T divided by E. Yes, V naught into gamma into 100 minus 0 means it is 100. Now what is cancel? V naught. What is cancel? Gamma. So what is coming relation here? T will become equal to Vt minus V naught divided by V100 minus V naught into 100. This is the coming relation on the board here for a liquid thermometer. T is the unknown temperature. What is T? Is the unknown temperature, required temperature. V naught is the, yes, initial volume of a liquid or volume of a liquid at 0 degrees Celsius. Volume of a liquid at 0 degrees Celsius. This is the volume of a liquid at 100 degree Celsius. And here is the volume of a liquid at unknown temperature. Volume of a liquid at unknown temperature. So with the help of this relation, we can find out the unknown temperature. Unknown temperature for a liquid thermometer.